Welcome to this explainer. We usually tend to put the natural world into neat little boxes. We've got water over here and carbon over there. But the reality? Our planet actually operates as one massive, intricately connected machine. Today, we're going to peek under the hood and look at the hidden machinery of Earth to understand how these two vital cycles totally depend on one another to keep our world functioning.
So how exactly do a single drop of water and a molecule of carbon actually cross paths to shape our global climate? Well, it's not just a passing interaction. Their relationship is basically the foundation of life and climate regulation on Earth. When one cycle shifts, it literally pulls the other right along with it.
To make sense of all this, we're going to map out the system using 4 distinct pillars: vegetation, the atmosphere, oceans, and the cryosphere. And then we'll wrap up by looking at the delicate global balance they create together.
All right, let's jump right into Pillar 1, vegetation, also known as the biological pump.
Think about a tree for a second. It's simultaneously acting as a water pathway and a massive carbon sink. It pulls moisture from the soil through its roots and essentially exhales it back out into the air through its leaves, a process called transpiration. But right at that very same moment, it is inhaling carbon dioxide from the atmosphere to fuel photosynthesis, locking that carbon away in its trunk, branches, and roots. They are the living engines driving both systems.
Here's the crucial takeaway. Water availability directly dictates plant growth, meaning the two cycles are biologically locked together. If a forest gets plenty of rain, it booms. That rapid growth means it can pull way more carbon out of the air while simultaneously pumping tons of water vapor back up into the sky. But take away that water, photosynthesis slows way down, and the plant's ability to store carbon just plummets. So to sum up this first pillar, plants are the living, breathing green link keeping everything in motion. They absorb CO2 and water, store the carbon, and release the water back out. It's just a beautifully elegant, continuous loop.
Now, all that moisture and gas released by the vegetation has to go somewhere, right? That links our green Earth directly to the skies above.
Which brings us to Pillar 2, the atmosphere, or the invisible highway.
The atmosphere is basically a massive dual-purpose transit system. For water, it acts as a temporary storage facility, using winds to carry moisture thousands of miles before dumping it as rain or snow. For carbon, it holds it primarily as CO2 and methane, constantly trading those greenhouse gases back and forth with the soil, the oceans, and the plants we just talked about.
And here is where things get super intense. More carbon means more heat, which fundamentally rewires how water moves through the air. As CO2 goes up, the greenhouse effect kicks into high gear, and global temperatures rise. When the air gets hotter, it evaporates way more water from the surface and completely scrambles our normal weather patterns. A shift in the carbon cycle creates an immediate, dramatic shift in the water cycle.
The really wild thing to remember here is that because water vapor is actually a greenhouse gas itself, the atmosphere creates a powerful positive feedback loop. More CO2 causes warming, which creates more water vapor, which causes, you guessed it, even more warming. They are completely, inextricably tangled up in the air around us.
Okay, let's dive into Pillar 3, the oceans, our giant planetary reservoirs.
Get this, a staggering 97% of Earth's water is sitting right there in the oceans. So the next time you feel a raindrop on your face, remember that you are almost certainly feeling water that used to be part of the ocean. While they are obviously the main engine for the water cycle through evaporation, oceans are also giant sponges for carbon. They suck up massive quantities of CO2 straight from the air. Then, this amazing mechanism called the biological carbon pump takes over. It drags organic matter from the sunny surface waters all the way down into the dark abyss, locking that carbon away for centuries. But here's the catch, and it's a big one. The temperature of the water runs the whole show. As the planet warms up, a warmer ocean is aggressively going to evaporate more water, fueling heavier storms. But fundamentally, hot water just cannot hold as much dissolved CO2 as cold water. So, as things heat up, the ocean's ability to act as a reliable carbon sponge actually gets weaker. To wrap up the oceans, they are the absolute heavyweight champions of storage. They constantly trade water and carbon with that invisible highway above us. But their efficiency is completely tied to global temperatures.
Which brings us to our fourth and honestly most volatile pillar, the cryosphere, also known as the frozen trigger.
We're talking about glaciers, ice sheets, and permafrost here. On the water side, these giant blocks of ice are hoarding huge reserves of fresh water, keeping it safely out of active circulation. But on the carbon side,
It's not just ice. We have permafrost, frozen soil that is packed with absolutely massive amounts of ancient frozen plant and animal matter that's been locked away for millennia.
Now let's trace this chain reaction because it is wild. Step 1. Global temperatures increase. Step 2. The ice and permafrost start thawing out. Step 3. All that stored water pours into the rivers and oceans, raising sea levels. But step 4 is the real kicker. That thawing organic matter starts rotting, burping out huge spikes of CO2 and methane, which drops us right into step 5, an intensified greenhouse effect, leading perfectly straight to step 6, even more warming and melting.
The source data we're exploring highlights something critical. The thawing of the cryosphere is literally a planetary trigger. It's not just sitting there passively melting, it becomes a dominant driver of climate change, dumping excess water and carbon into an already overloaded system.
So, cryosphere summary, it keeps both cycles safely locked away. But once it melts, it hits the gas pedal on planetary warming. It transfers all those dormant stores of water and carbon straight back into the biological pump, the atmosphere, and the oceans.
All right, let's bring it all together for our conclusion, a delicate global balance. We zoom out and look at the whole picture. These massive systems are basically engaged in this incredibly delicate intertwined dance. You literally cannot change the amount of carbon in the atmosphere without altering the ocean's temperature. You can't change rainfall without messing with vegetation's ability to store carbon. And you definitely cannot warm up the cryosphere without sending feedback shock waves through every other system on the globe. So we'll leave you with this final thought. In a world where water and carbon are so deeply and unavoidably connected, what happens when human activity permanently warps just one of these pillars? Can we really afford to disrupt even a single piece of this puzzle? Thanks so much for joining us for this explainer, and we hope you now see our Earth's natural cycles in a totally new, interconnected light.